Hey guys, welcome back to the channel. In this video, we'll be continuing our knowledge of rational expressions by talking about multiplying rational expressions. This will be the third part of the rational expressions portion of the rational functions playlist. This is a really important skill because these operations for rational functions are used everywhere when it comes to simplifying functions in general, especially once we start composing functions and we talk about complex fractions, and also even when we start to graph rational functions. And this is a skill you guys need to master. Also factoring as well, but we'll get there eventually. Alright, so let's just hop right into it. So before we actually talk about how we multiply rational functions, let's talk about in the past. Alright, so in like the third grade, right, we said multiplying and dividing fractions. 1 over 3 times 1/3 times 1/9. Okay, so we multiply the numerator by the so we multiply the numerators together. So 1 times 1, and then we multiply the denominators as well. We also had cases where, like, if we had 3 over 7 times 4 over 9. Okay, this would, so if we had anything with common factors, that would cancel out if they were in the, if one was a numerator, one was a denominator. All right, so 1, so that 3 becomes into 1, and that 9 becomes 3. All right, so that becomes 4 of 21. All right, so so it's the same case. Really, we want to be able to factor a rational function to find anything that cancels out in the numerators and denominators. So, all right, so we have in today's example, we have the expression x squared plus 2x minus 3 over x squared plus 8x plus 16 times 3x plus 12 over x minus 1. Okay, so the first thing you want to do is you want to get everything in the simplest form. So factor to simplest. Alright guys, sorry about that. Alright, so we start off by factoring this fraction here. This fraction factors out. Alright, so you guess in the check method. Alright, it works every single time. Alright, so when we're factoring something, we say, okay, so what two factors multiply out to -3 but also add up to +2? Okay, and so, alright, so we know this, one of them has to be positive, one of them has to be negative. Alright, so x, and this is x as well. And so, thinking about it for a second, okay, we need to have a positive value. Oops. Sorry about that, guys. Alright, so -3. So that's only possible with 3 and 1. And we get +3, so 3 needs to be positive. 1 needs to be negative. Okay. And if you guys want me to do more factoring problems, check out that playlist. It should be up in the future real soon, and we'll be covering more about that in polynomials. In fact, okay. So check out the polynomials playlist if you guys want to talk. If you guys want to hear more about that. Sorry for hitting the mic right there. Okay, and so this one factors out to, well, all right. So we know the x squared, there's only one factor of x. So x times x gives us x squared. And we need to know what gives us x plus, or what will multiply out to 16, but will add up to 8. So that's 4. All right, so the two positive signs mean, okay, there's no negatives here. So this has to be positive 4, and so 4 plus 4 is 8. So that's why it's 4 x plus 4 times x plus 4. Or you can write it as x plus 4 squared. All right, and then so the common factor here in this one here, we just take out a 3x minus 4, or sorry, x plus 4. And we have x minus 1. Okay. X plus 4, not 1. Okay, sorry about that, guys. Okay, now we factor out. Now we cancel out any factors they have in common. So in this fraction here, or in this fraction here, there's x plus there's x minus 1 in the numerator and x minus 1 in the denominator. In the second fraction, those become 1. All right, this x plus 4, a factor of x plus 4, in this denominator cancels out with the numerator of the second fraction. That becomes 1 here. Okay, so now we have 3 times x plus 3 over x plus 4. And so essentially we cancel, so we factor the numerators and denominators in each fraction, cancel everything out that each fraction has in common in the numerator and denominator. So if there's something common in this numerator and something common in this denominator, they cancel if they're the exact same thing. And then we take what's left, and that's our simplest form. You can leave it factored out. So in our case, we had left over 3 times x plus 3 and in the numerator, and if we multiply this out, we just have x plus 4 in the denominator. So essentially, we just have that left over, and that's our solution. All right, you could just multiply by 3x, or 3x plus 9 over x plus 4. Either way is correct, but I know a lot of teachers and a lot of exams want it in the simplest form possible. So that'll do it for today, guys. We'll see you guys in the next one. Later.